Okay, so hello everyone. Today we're going to talk about SQL and Slick. It will be a short session by me, and hope you enjoy and learn through the presentation. So we'll just start from SQL and what is SQL. So SQL stands for a structural query language. So it lets us access and manipulate the databases. Okay, so it is mainly a database query language, and it has become a standard in the industry and almost all over the world. It is like recognized as a database query language, or as or as the name goes, the structured query language. Let's start with some common queries in SQL, so that we can refresh our SQL queries and also connect it with Slick in Scala. Okay, so let's start.
So these are some of the few like SQL queries. We don't need to go so much depth into it. I just want to connect the Slick with SQL. So showing a few queries before that. So this is a little longer. So we are selecting a lot of columns here from a table called call, and we are joining the table with another tables on the basis of the ID. One is the employee ID, and the other is also an employee ID. And then group by employee ID, and we are grouping it by three columns. Then order by employee ID ascending who's been. We are ordering by the employee ID in ascending order. Okay, so we'll not go in much depth. These are just a few examples. So if you want to go into more depth into it, so I found a few good resources. So this is the resource from where I've collected those commands, and
Hey,
it
Simona, just hold on. I think Pavan is unable to see your screen. We can see it though, Pavan. Can you try to fix it at your end? Yep, and please continue, Samantha. Samantha, please continue.
yes. So, this one of the websites. So you can just look into it. This commerce may be a bit complex. So before moving into it, you can look into example some example SQL queries, because the comments are literally 12 to 15 lines long. So the SQL queries can be 12 to 15 lines long in order to get the exact data that you want. So it might be long. So these are some examples, but they're a bit advanced. So yeah, just we can do a bit of practice before we begin. So okay, so just a bit of refresher of the SQL and how they look and what are the uses actually. So we are selecting things from a table based on some few conditions. So yeah, these are some these are just some few examples. So now how does it connect to Sleep? Okay. So Sleep is actually a library of Scala. So it is said that it's a modern database query and access library for Scala. So it allows you to work with stored data almost as if you're using Scala collections. And one thing to note is that okay, so actually when I was looking over at Sleep, I actually found a very good document. I just want to give you a look into it. It's a very good document which explains, the components of Sleep. What are the advantages of Sleep? What are the functions of Sleep? And what is new in Sleep 3? So it's a very good video. I don't think it's on Sleep 3 because it's on 2013 and Sleep 3 was published I think later. So yeah, so this is a very good document to get an overview of Sleep, and it's very interesting as well. So yeah, so let's see what we have next. So the next thing we have is So Sleep. So as you can see, it is a function relational mapping language. So what is function relational mapping? So we need not go into the depth of function relational mapping, but the thing is that Sleep uses the Scala collections mainly. Mainly the Scala collections is the one thing that is used very rigorously in Sleep. Like it uses the Scala collections to do to do the database queries. Okay, so that's why it is called functional relational mapping. So we don't have to write SQL commands here. We can use the Scala collections only to do database queries, and it makes the things much easier. So while using Slick, you may or may not know the SQL language, so it's okay. So we can do the SQL queries using the Scala collections. So yeah, so there's a good base to look into. It gives us a good introduction about the Slick. So here it is also told that it's a functional relational mapping. In the first line here it is written is the functional programmers have long suffered the object relational and object map impedance mismatches when connecting to relational databases. So Slick's new functional relational mapping paradigm allows mapping to be compared with Scala with loose coupling minimal configuration requirements. Yes, the configuration is not so hard. It's it's non-trivial. So we can configure it very easily. And, yeah. So let's move on to the yeah. So the first step we have to do to set up Slick in our system is to add the library dependencies. So here we're adding the dependency with Slick. H2 database. So H2 database is actually a library. It's actually a database library. So and we're using the logback for logging. So logging means saving the file system. So in our project only we have the logback is mandatory. Logback is it is mostly used like in our project we are using this logback called I'm not sure about that. But in most of the modules that I've seen in the Windows SBT, so most of them have the logback or the SLF4J. So SLF4J also logs files. So logback also logs files and SLF4J also logs the files. So actually yesterday I was having one error which I had shown to Pranjota actually. So in that case, what happened is that the database was saved in the log files by two different what I can call it, two different libraries. Maybe. So one is the SLF4J and the other is the logback. So I had to choose one. So there was this conflict. So that's when I came to know that the Scala actually saves the log files whenever we run a query. But I don't know yet if it is mandatory or not. I'll just write the question down so that I can find on it. You just give me a moment. Logback mandatory. Okay, I'll just try to answer you in the next episode. Okay, so the next is the application.conf. So we have to set up the application.conf before moving on to the Slick queries. So we just set up the application.conf like this. I don't have very much details of about these properties, but I've just gone through the examples, and here are some of the examples that we have used in our own project. Actually, we have used this in our own project. We have used this application.conf in one of our modules called as SQLDB or SQLDB. So in SQLDB, we have used this in this one. So application.conf. And yes, so what do we do is that we just use the transactional to run the queries. So SQLDB module is handling all these queries. Okay, all the action in the queries like inserting or extracting, all these things is done by this module, and we are extending this module into our other modules. Like we are using this module, we are using the SQLDB module in our tables and in our scheduler engine as well. So yeah, so the SQLDB has this file called as application.conf. So you can see that it is similar to what is given in here. So after that, the next thing we need to do is that we need to create a database object to run our queries and generate the schema. Okay. So we need to refer to the database. In this case, we are using the SQL database. So to refer to the SQL database, we'll use an object. Okay. So this variable called as db, or yeah, this variable db will refer to this database. So we need to like configure this. So in our own project as well, we have used this uh, in here. So we are using this here. So we are referring to the database using the db. The next thing we need to do is to define our schema. Okay. So how to define our schema? So how to define our schema? So let's see. So we'll just use our own project to see how we have defined our schema. So we have defined our schema here. Okay, so here we have defined our schema. In in this file, what we do is that we actually name the columns, like what will be the columns in the table, like username, man, active, date, and we just mention the type. Okay, and we mention them in a case class, and case class has many advantages in this method. So the advantages actually, right now, yes.
Yeah, what about declaring more complex, like object within object and custom types? Can we do this?
I don't think in tables we can do that.
Schema,
Maybe I don't know. Uh, so the schema definitions, as far as I know, these are like one line. I mean, for one column, it is only one line.
What about representing complex data? How then more complex data?
Okay, more complex data. Like for example,
Data within data?
okay, in a column.
Nested data.
Okay, like in a column, like how can there be a nested data?
Column referring to some other data.
Okay, okay. Like the foreign key concept.
Yes, you can say like that.
Okay, so the primary key, foreign key are like handled differently. So and for like more complex data types, about that actually I don't have much exposure to that. So I'll just write it down. Just try to find out if there are like more complex data types. Okay, I'll just write it down. And for the foreign key and primary key concepts, we are like we'll see in the we'll talk about this in the next section.
Can we do like integer don't have value beyond 10, or string don't have number is not certain that 10?
Okay, this one. So like this part, okay, I have okay. So I have not done this type of queries yet. So let me show you like what I have done till far, and this type of queries, yeah, I will just write it down. There's an indications in the data.
Pavan,
What about security?
Pavan, are you asking like that what if the columns will have null values, right?
Yeah, one of the restrictions. I mean the constraints. What about constraints?
Okay. Constraints, I think you have to do in the while you are defining the schema here, right? Here you can define different you can define primary key, foreign key, or if something is nullable, if something is not nullable, you can define all kind of. I mean, this is the regular SQL queries. Although in the case classes, whenever a value is nullable, you have to make it optional. So that's the way it works. I don't know, were you asking that or you were asking something else?
I mean how to, yes, something like that. How to represent data more like it's,
We have also represented it mainly here.
okay, fine.
So okay, so I'll just look into this in more depth. And the next thing we do is that we are only defining the schema here. So here only, we're only defining the name and the type of columns. So we can also do it without the case class as well. So in many examples that I've seen, so let me give an example. In many of the examples that I've seen, many of them don't use case class as well. We can directly refer them in the table object. But there's some advantage to the case classes which I've forgotten right now. I will just tell you them in the next session. So there are many advantages of the case classes. So that's why we use the case class and then we extend the table where we actually define the table object. Okay, so here we actually define the table object where we extend the table. Okay. And then here what we do is that for example here these are the column names, which is the ID, the sender, and the content. So in the ID, we are saying that whatever value is in the ID, it should be of the type long, and in the sender it should be of the type string, and in the content it should be of the type string. And what is this message in quotes and then ID in quotes? So actually this ID, sender, and content, these are the values which we are referring to the column. Okay, so which we are referring to the column in the table. Okay, so what happens is that this ID we can see in the Scala project. But when the project is saved, the table name is this. Okay. When the table is saved in the database, so it will be saved like this. Like if I write a message here, the name of the message table in the database will be message, and the column name of this ID in the database will be ID, will be sender, and will be content. So we can write whatever the names we want here, but if the names are same, it will be much easier to follow. Okay. So yeah, so def ID equal to it should be of type long and its name should be ID, and O means O actually refers to the column. I've not gone very much depth into the O, but what it means is that it refers to the column ID. Okay, in this case, so this ID should be a primary key and O dot auto increment. So what it means is that whatever the primary key we have chosen for ID, so the Scala will increment it automatically, or the slick will increment it automatically. Like if the
One
idea
question:
is
can we make our own increment, rather than using the Scala's auto increment?
yes.
How can we use our own class which can do increment?
Okay, so either we can write the value manually, or we can write the menu we can insert the value manually. This is what we can do. I've written one, suppose my name, then two, suppose someone else's name, we can do it. But if we want to implement the increment function by ourselves, so yeah, we have to look into that. I've not tried it yet. Just write about that.
Sorry to come back up, Bob.
This one. So actually, I was saying that we can write our own IDs, and if we want to implement the increment function ourselves, the auto increment first, the auto increment of the ID by ourselves. I have not tried it yet, so I'll just
Okay, regarding auto increment, if we want to start from 1,000,
we'll have to write the first ID as 1,000, then it will increment on its own.
how can you show that? Do you have an
Actually, right now I can show because I had changed the implementation to H2, and the H2 part actually I'm facing a few problems. So I have to change the entire implementation to Postgres, then only I will be able to show it. Okay. Okay, so yeah, the increment function, yes, we'll have to make some tables and we'll have to do the increment function. And most of the people actually in the increment function, yeah. Okay, I'll just
Could you also please tell me what is def star? Star.
yeah, yes, sir. Yes, I will. I'm just coming to it in the next thing. Okay. So let me show you how we have done this in our own project. So in our own project, here is what we have done. The exact same thing only. So here we have using like we have here we have in the account tables here the column username we have referred to it as the primary key, and then yes, the primary key, and we can also like make a foreign key as well. So let me show you how a foreign key is made. The foreign key is used in the transaction table. Right? So in the transaction table, we have a foreign key, and how we have made this foreign key is that we have made this user as the foreign key. Okay, so and the name of the foreign key is called as transaction user, and we have linked it to the variable or sorry the column name known as username. Like this is the username. Okay, this is the username. We have linked. Sorry, we have linked the user in the transaction table. We have made it as the foreign key of yeah. So user is the foreign key of this username in the account table. Okay, this is the username, and here this user is a foreign key, and it refers. I mean, it actually refers to the username of the account table. So this is how we'll like make the foreign key, and we have to write this keyword for this foreign key. Okay, so let me go to the star. So what is the star exactly? So let me move to that. What exactly is the star? What is the star here? So star method provides a default projection that maps between columns in the table and instances of our case class. Okay. So it may be, I mean, it may be difficult to understand from here. So for now, all we need to know is that this line allows us to create a database and get back messages instead of tuples. So what we do here is that in the star, okay, so okay, it is very small here. Okay, so what we do here is that this line, what it does is that, I mean, to give you like a higher level overview, this account table to tuple, what it does is that it converts this case class into tuples. Okay, this account table dot tuple. Okay, and this account table dot unapply, what it does is that it converts the tuple back to case classes. So when we do the star method, it actually extracts, so it actually maps to these columns. It extracts the values. So like like for example, if we do something like let me show you. I should have an
Is it? I have a question. Is it like the normal star that we use in SQL?
yes, it's like a normal star. It's like a normal star only. So, but we have a more like we have some more functionalities here. Like we can convert this case class into tuple, and we can convert the tuple back to a case class using this star. And the practical implementation, sorry, I don't have that right now. So I will I have an example of a star later in the slides. Maybe I will be able to show you. So like so is it up here or So is that doubt clear, or I should be like
No, it's fine.
okay?
So it's mainly is the, like, this is what I have understood. It's like
Yes, yes, it's like very similar to that.
can we do joining here as well? Like if you want to do join
Yes, right. Yes.
now.
Like we can do so. We can do so. Okay, so there are some queries for join. So maybe I don't have right now in my hand, but I can show you later.
Also, what kind of join, like inner join, outer join? There's several kind of joins. So does it support all or some? Only few?
Yes, right. So in most of the cases, I think it supports most of them. As you can see from here. So these are some of the joins. Uh, like like as you can see, when you write only join, it does the inner join, and
So
when
where
you
is
write
def star? There is a def star. Syntax is different than what we have displayed.
no, but actually this one is not the definition of the table. So the definition of table is somewhere I think here. Here. So here is written def. Okay. So we can write it simply as well. But this implementation that we have used gives us more it gives us more functionality. Like we can convert a case class back to a tuple and then change the tuple back to a case class. So when you write like this, and the application of this, I don't have that yet. I just looked it up and yeah, I just have to find some applications or like where this case class back to a tuple and tuple back to a case class will be used. So I'll just try to find it out. I'll just write it down. Okay, I'm just writing it down. And yeah, so this def star can be found in almost all the tables. I mean, like I have found in almost all the tables that I've seen. So here also they have used the def star. And the joins, these are some of the joins. Yeah, this is the inner join, and if you just write join, it will just do the inner join. So join, inner join, then left outer join, then right outer join, then full outer join. So we can do these joins here. So like most of the SQL queries can be done in Slick. I mean after Slick 3 it has like advanced level. So is it clear or?
Yes, it is.
Yeah. Okay, so let's move to the next one. So yeah, what is lifted embedding? So all that we are doing here, okay, okay. So let me show you one example of lifted embedding before its definition. So this part, what we're writing here is this file messages equal to table query message table. So what happens is that what we are doing here is that in our own project one thing, we are like referring all the queries that we'll do on the table. I mean whatever queries we'll do on the table. Okay. We'll refer all the queries into one general variable called this account table query. So this variable we will use for all the queries. Okay. Like accountable, for example, accountable plus equal to account will insert something. Then accountable dot filter as username equal to user, it will like filter something. Okay. Like all the queries related to the table will be referred by the accountable query. So this is one example of a very important concept in Slick, which is called as lifted embedding. So in lifted embedding, what we do is that we actually compose objects or some variables to refer to a mapping or to refer to a database query. Like we group the general queries together into one single object or a single variable. So this terminology is called as the lifted embedding. Then let me read the first line here. So define data types to store raw data. So this one is the lifted embedding. Then define table queries and combinators to build useful queries before we run them against the database. So we are referring to the database, but we have not run any queries yet. But we are still referring to the database using this variable. So this is one example of lifted embedding. So Slick, the lifted embedding is everywhere. So let me go to the next one. So this is one example of lifted embedding. So like we are referring to all the table queries using the messages. So let me go. So what we are doing here exactly is yeah. So Slick allows us to define and compose queries in advance of running them against the database. So before running them against the database, we can define and compose them. Okay. So we have just defined the query. Okay. We have not done anything with it. So here we've done something. Okay. So hull says equal to message dot filter dot sender equal to like it will filter all the messages where the sender is hull. Okay. But we have not run it yet. Okay. It should be clear. Like we are moving step by step. Firstly, we have defined the table queries. Okay. Like all the queries we have referred to this variable or as messages. Okay. Now next thing we have done is that we have sorry. Okay, it's a simple cup of tea, not pouring. Okay, so this here we are like referring to all those messages where the sender is hull. Okay, so this hull says is referring to them, but we have not run it yet. So we are like building block by block. Okay, this entire query we are like building it block by block. Okay, this is like one of the very good features of Sleep. It makes the it actually makes the things much simpler. So yeah, so before moving on, let me introduce you to the ZDBC. Okay. So in this query, we have to run it. We'll like move to the running in the next few slides. So before that, let me introduce you to ZDBC. So ZDBC, you must be very familiar. It is mainly used to connect the database with the ZVM. So ZDBC works with connection strings, which are like URLs, like the. Okay, so let me give you an example of ZDBC. So, and for some detailed overview of ZDBC, you can refer to uh, this web page. So ZDBC helps you to write Java applications and in our case Scala applications as well that manage these three programming activities. So connect your data source like a database and then send queries and update the statement to the database, retrieve and process the results received from the database in answer to your query. So it's a Java API which actually it can access any kind of tabular data, especially data stored in relational database. So for like more into depth, this is how this like entire page is on ZDBC. So in our case, how we are using the ZDBC, let me show you that. So how we are using the ZDBC? First, we have to connect. We have to connect the database using the ZDBC. So how do we connect? Like this is the setup of how we will connect. But in our case, how we've connected to the database using the ZDBC is like this. Okay. So here we have connected it. So there are a few things that needs to be done, but here is an example how we will connect it. Okay. So for example, if I remove this is the main actually connection part. Okay. This is a URL. Okay, this is the URL to which we'll connect. Okay. So we are using this ZDBC URL. Okay, we are using this ZDBC URL to connect to the S3 database. Okay. So let me give you a small example how we have connected. So in the next page, I will just connect to the S3 database. Okay. So let me give an example. Let me go to the file. Actually, I had like tried using the S2 in the library to see my results, but in the first few days, like I was like unable to do that. So I actually installed the S2 database externally, and then did a few things there. So how we will do it is like this. So the command I have to write yes. this command I wrote, and so yeah, this is the the S2 database. So to connect to the S2 database, so this is a driver of the S2, okay? And this is the ZDBC. We are connecting using this part, the ZDBC part. Okay? So this URL is very necessary. Okay, so like this URL, this is an example. Okay, but in here the database we're using is S2 only. But the thing is that the S2 is in the form of a library here, but here we're using an external one. So this will not connect to this one. Okay, to be clear, this project will not connect to this S2 database. It will connect to the S2 database in the SBT project. So this is the URL. Okay, this is the URL we have to pass here in order to connect. I'm just giving an example. And when you connect, it will show you this. And here we can run the queries here and all this thing. Okay. This is how the ZDBC works. It helps us to connect to the database. So these are some of the these actually. Okay, now DBIO and DBIO action. So I have not gone into much detail into the DBIO action, but whenever we have to run or put into action some query, in here what we have done. So in here what we have done is we have just defined the query. We have not done anything. We have done nothing. Okay, so here to put the queries into action, we'll use this DBIO and DBIO action. So whenever we have to run the queries, it has to be of type DBIO for the action to occur. Okay. So let me show you, for example. So for example, we need to insert some data, some test data. We'll define a helper method to create a few test messages for demonstration. So these are some of the things. Let's see here. So here what we've done is that we have defined a simple sequence of messages. Okay. So these are some of the table column values. Okay. This and this. Okay. So what we've done is that we'll insert this data into a table, and the name of our table was messages. So let me move back and show you what was the name of our table. It was messages. We have defined messages already. So here you can see this is the table for you. Okay. It refers to the table. So whatever actions that will incur on the table will be referred to this. So what we are doing here, is that we are trying to insert it. So in order to insert it, we have to give it as type. We have to give the function as type. It's a function value actually. So it's an insert of type DBIO. Okay. Without the type DBIO, it will not work. DBIO is the main one which does the action. So is the main driver of the action. So messages plus equal to phrase data. So what we will do is that it will add this phrase data into the messages. But in our project, you may think you may look at something different. So let me show you how we have done it in the project. So it was very difficult to understand at first because it was very different from the example that let's see. So what we have done here is that we have written one insert function here. So can you see my screen? I think it is much smaller. Let me try to increase the size. Okay, it was somewhere here. So yeah. Okay, so what we have done here is that we have done one insert function, and here we have written that await.result transaction. So we have used the await because the result may take some time for us. So to get a result, it may take some time. And the other thing is that we have used a transactional. So what is this transactional? Okay. So this transactional. So I will go into a transaction later on, but inside you can see we have used the exact same thing. We have used the DBIO.sequence accountable query plus equal to account. Accountable query is referring to the database actions, and this this account table query plus equal to account will add whatever the data of the account we put here. And whatever the account data we pass here, it will be added to the table. So, like to run these actions, we need the DBI, okay? And the other thing is the gate, okay? So, as you can see here, okay? Yes. Let me come to this example a little later on. After I finish this part, okay? So, this file insert. So, we have like implemented it a little differently in our own project. And the other thing is that this query has not run yet. Okay, we have made it of type DBIO, but it has not run yet. Okay, we have like written the function to insert data into a table, but it has not run it. To run it, what we do is that we have to write another variable called as this file insert action equal to db.run insert. Okay, db.run. What is db.run? This is the main thing. Okay, this is the like the query. The query is here. Okay, the query is here, but it is not related to the database here. Okay, when we run the db.run insert. Okay, this insert like this insert function shall loop is like run when we put it inside the db.run. Okay, here is the db.run insert. Okay, so it will run it will relate to a database and it will run this function in the database. So this is the main thing. And to extract the results, we have another query. Okay, this is the file. So this is not another query. We have to extract it using to get the result. We have to do this one. File row count equal to await.result insert action command 2.seconds, and await.result is used for a future, the future result may come after some time. So await.result is used to wait until the result comes. Okay, and this 2.seconds you will wait for 2 seconds. Okay, and yes, so it will be stored in the variable row count. Whatever the result will be, it will be stored in the variable.
Await result will return future response. Await dot result.
So I don't understand your question.
Await dot will it reach to the class file or what? On the row count. It will return manually. From the code I can see it returns the data, right?
Okay. So the awaited result, what it will do is that it will return the rows. Okay, the rows which fulfill the condition. Whatever query we have written.
The integer here, not the future bracket integer.
Yes, right. So yeah. Yes. Yes. It will return the row count. So it will return the number of rows it has affected. Yes.
Okay.
So yeah. So this is what we have done. But in the project, okay, I have coming back to the project in order to be clear about few things. Here I've seen that there is no db.run. Where is the db.run? Where is it? Okay. So I was actually searching for the db.run for an entire day, one time, and then in a transactional. Later on I saw the transactional, but I
was searching entire day.
yes, where is the db.run? I was I was trying to find it when I was first given this task. So there I found the db.run, but it was not in a similar form that we had seen in these cases. Okay, so so this is I think the beauty of the function programming. I think. So all the db.runs are congregated in one place. Whatever the db.runs, all the db.runs will be handled by this function called transaction. Whenever in this db.run. So I don't think this is the db.run I was referring to. Yes, this is where is it? Yeah, this is one of the db.runs. So there are many db.runs. So what happens is that the transactional function will handle all the db.runs in all the files. Okay, So this transactional will handle this developer, and whatever the function, it will come in this place. Okay. So here I have written the insert function. When I run this transactional and this query, so this insert function will come in this place, and thus this developer will process the insert function. Okay, this is how it is working in our process. So this one example. Okay, here. So here is what I want to show you is that I want to show how like a simple like some simple queries. Okay, so like when we come from SQL to Slick, how will it connect the dots? Like between this between the SQL language and the Slick language. So to connect the dots, here are a few things, like a few queries, just to give you a high level overview about how the query changes. So this select, okay. So the convoy was asking about a select. So when we like do this in the SQL language, so we can run this in Sleek only. Okay, this query we can run it in Sleek only, but in terms of SQL language. So this I will run, and the converting to Sleek language, this is one line. This is people, not result. And what is people? People is actually what we refer to the table. Okay, we refer to the table queries through the people object. So let me show you how they use the people object. Here, see, people equal to table query people. So all the queries that will like happen in the table will be referred by the people. Okay. So let me show you the select will be like this, and the in Slick, in pure Slick, it will be like this, and in SQL, it is like this. Okay. Oh, sorry, this is on different one. So this is on different one. There is select age compare. This like we're like selecting the age and the name of the person. So we can do it like this, and Slick will be like this, and where in SQL looks like this. From person where age greater than equal to 18, and then Slick it will be done using the filter function. The order by is done like this. Select star from person, order by is, and then Slick is done by this. You can shortcut. And the aggregations is done by this. Like aggregations with average, maximum, all this stuff. So we can do this. And in Slick we use the map function, and then use this dot next dot user. So these are some of the few queries. So you can go through them. So these are some joins. So it's a beautiful book. I mean, all the things are here. So okay, there are a lot of stuff. Okay, so really don't. Okay, so yeah. So these are few of the examples of how the SQL query changes in Slick, and it like we'll get like quite used to it once we like see a few queries here. Yes. So this is like a few of the example queries. Okay. So let me give you a very simple example how it looks overall. Okay. When you apply all the concepts, how it looks overall. So here it is simple. So here we connect to the ZDBC. I mean, here we sorry. So here we connect through the ZDBC. Okay. So the setup database. So we are like connecting to the H2 using the ZDBC. So we use setting up them, and here we are like writing the case classes to mention the columns and the type. And here we are like defining the table. So here we are defining the table, and these are the columns, and these columns, and here he is like writing on foreign key here. Then here he is writing some common function, some convenient functions here. So here album table is referring to all the table, like all the queries that will be done on the album table. So he's referring to all the queries in the album table through this variable for his album table. Okay? So here what he's doing is that table, the, the album table of schema. What he's doing is that he's adding both the tables actually. Like this is the schema of the album table and this is the schema of the song table. So he's adding both the schemas together. And these are some of the few functions that he has created. So yeah, so these are some of the few functions he has created to query around the table. Here is written the join as well. Then executing the actions. So to execute the actions, here also use that in. So this one. Yes, this is the db.run. Okay. So here the db.run is used to execute the queries. Okay. Whatever the queries is used and the object of the action. So whatever the action we put here, it could be inserted, it could be joined. The type should be dbi. Okay. Without this type, it cannot run. Okay, so yeah. Here is the dbi. And this is the entire XP the program is written to like to write the queries for Sql. So these are like easy and beautiful. So yeah, so this is the screenshot of that final that program. Yeah, so that's all I have for.
So thank you. Thank you, everyone. That was all that I had for today's presentation. Hope you all learned a lot and enjoyed it. Thank you.